Hello and welcome to our introduction on our carbon negative power plants. So today we're going to talk about one of the key aspects of what we make in our carbon negative power plants, and that's our biochar. So first off, we're going to start high level with what is biochar. Now biochar, in its name, char from charcoal, it's a type of charred substance. The simplest and best way I describe it is you think about a campfire where someone is burning wood to make fire. Now obviously that wood is burning because of the energy inside the wood, and it's combusting because of the oxygen, the heat and the oxygen. Biochar is made in a very, very similar process except for the absence of oxygen. So we have no oxygen in the process. So because of this, the wood does not physically burn. There's no actual flames. So the heat decomposes the biomass or the wood and turns it into a mixture of different substances. Obviously the char itself, syngas or the gas, and sometimes tar and sometimes wood vinegar, depending on the process. So a good way to think about it and a good answer to the question is, what is biochar? It is very similar to charcoal, but the difference is charcoal will have oxygen that allows it to burn, whereas biochar is a lot more limited. So here's an example. This is the biochar that we make out of our plant. Now, biochar is by its nature carbon negative. So what we mean by that is the biochar is filled with a very high percentage of fixed carbon. Now fixed carbon is carbon, it's carbon dioxide, it's carbon monoxide, it's carbon, it's the backbone of humans. It's what every life is made of on this planet. So it's integral to society. Now, we'll stick with wood here, but as the tree or timber or wood grows, that obviously sucks in CO2 and carbon into its timber. Now, as that tree comes to the end of its life, if that tree falls over and then decomposes, that carbon is then released back into the atmosphere. So that's the traditional cycle of what happens. A percentage of that carbon is buried slowly underground, through erosion, through whether it's avalanches, through just standard decay, which then buries further and further underground. It actually then begins to fossilize, which is what creates coal. So coal is just timber or different forms of biomass or many different forms of organic substance that's been fossilized for centuries, if not millennia, till it becomes a coal. And that's how we have different grades and different types and quantities of coal, whether it's thermal coal, coking coal, different types of coal. Now, one of the issues the global climate is having at the moment is, as that coal is dug out the ground, it's the same for oil and gas, it's then released back into the atmosphere, which has now been sequestered for thousands of years. So the key beauty behind biochar is we're taking this carbon that's about to be released back into the atmosphere upon that plant's death, and we are capturing it in solid carbon, and then we're doing something with it, which we're going to go through in a moment. There's a few different uses for it. So that brings us to the next stage, which is what is the uses of biochar. Now, let me just tear this away. Bear with me, sorry. It's going to get a little bit black, but biochar is carbon, so it can be black. That's completely fine. Okay, so we're going to talk about the key uses of biochar. Now, there's probably four main categories that we categorize biochar as, what it goes into. Now, biochar uses. So one, probably first and foremost, this is what gets the most, let's say, publicity, is agriculture. Two is, we'll call it heavy industry. Three, we'll call it energy, or even just thermal. Apologies again for my writing. Definitely not my skill set is writing or spelling. And then four is a bit more specialized, metallurgical. Metallurgical as in metal production. So metal production always uses a large percentage of carbon. So let's talk about these four for a moment. Metallurgical and thermal. What we're doing here is carbon, biochar, has a calorific value, and it's a very high and it's a very good calorific value because carbon itself is it has a good calorific value. So here what this is doing is it's been usually burnt or combusted for some form of energy. It could be heat, it could be electricity, it could be steam, so it's combusted. Energy is produced and that energy has a value, so it's good. It's considered net zero energy, but the challenge is after that carbon is burnt or combusted, the carbon or the CO2 is released back into the atmosphere. So one of the key purposes with biochar is that we try and avoid that carbon going back into the atmosphere. Metallurgical, this is where we're using a much higher grade of biochar, similar to what we're producing here, but it's used as the reductant in, say, steel making or magnesium production or even lithium production. They all use carbon as a reductant. Now that reductant is purely just a way to take oxygen out of the finished metal before it's finalized. So it's a very high quality of carbon. I mean, currently the industry uses coking coal or maybe recarburizer are some of the different terms for it. Again, it's a similar process. The carbon, a percentage of the carbon will go into the metal. It's actually not a large percentage. But the existing carbon will also go back into the atmosphere after it's been burned, because this is an energy process as well. So these two we don't focus on a lot at Carbon Negative. We focus heavily on agriculture and heavy industry. So now we're going to go into these two in a little bit more detail. So there's a lot of uses that we can talk about in agriculture, and we'll come back to some of them, but we're going to talk mainly about fertiliser. So fertiliser, as we know, is a fertiliser. It's used on most crops, whether it's a grain that's been grown for human consumption or a flower that's been harvested. So fertiliser is used everywhere. Now there's many, many different types of fertilisers. One of the most common is NPK, which is nitrogen, potassium and phosphorus, a blend that goes into the fertiliser, which is very beneficial for plants. So one of the key aspects around biochar for agriculture is that there's been many, many studies now, we've done some ourselves, that have demonstrated that a blend of 1, 2 or 3% biochar added into fertiliser can give a total reduction of 20 to 30% fertiliser used on the crop. Now, obviously, to do some quick, we don't need to do some numbers here, but you can see that cost saving of adding 1 to 3%, and we're saving a total volume usage of 20 to 30%. It's a very, very significant cost savings for the farmer or the agricultural user who's growing and using that fertiliser. So that's the key focus that we find, because there's a very, very high demand from our agricultural growers and our farmers that we work with. Now, there's a few others that will definitely, that I'll touch on, and this is things like lower water retention, greater water retention, lower water usage. This is when plantations or fields are watered, the biochar actually retains more water for a longer period of time. This is going to get me very dirty, for a longer period of time inside the soil. So that has a lot of water benefits for it. Also, just the general. There's a region in the Amazonas, Terra Pracha, which is where really biochar originated from thousands of years ago. And there's still residues today, I mean more than just residues, it's still very locked away in the soil. That's not just locked away the carbon for so long, but it's actually, these regions where it was used are still growing very, very strong, much better than the rest of the Amazonas region. So it shows that it just grows, it grows things a lot better. Now, to give you an example, here's a really, really great example. So here is a crop. This plantation was done with NPK, so standard fertilizer. This one here was done with a blend of biochar and NPK. Everything else is the exact same. The temperature, the water, the time. You can see the growth is significant. So, as I said, this is the primary use because it's not just beneficial for the crops, it means less fertilizer and more savings. So that's the key use we look at with agriculture. Now, heavy industry we're going to talk a bit more about as well. Heavy industry is also another very good one. Now, why this is different to the other two kind of industrial uses is when we say heavy industry, we're talking about using it in the process of heavy industry making, and it gets locked away or sequestered. So again, the key reasons we like agriculture is because it is considered net negative, meaning carbon is sequestered underground. So that's great. Heavy industry is the same because it's been used in a solid product and it's not been released into the atmosphere. Now, the two main things we like to look at are cement and concrete production, and asphalt. asphalt slash bitumen. I don't know how to spell bitumen, I'm sorry. Asphalt slash bitumen. Now, we've got some other examples here, so we shall come. Actually, I'll show you this one quickly. This is a very small volume of biochar we're talking about here. Here is a large scale production run. So they are utilised in large, usually 1 tonne bulker bags, where they're then transported to site or transported to the, say, the fertilising blending scenario. So there's a good example of the biochar production being made. Okay, here we're going to talk a little bit about probably more about cement, but there's a lot in bitumen as well. So this here is this was actually in Victoria, Australia, where biochar was blend at a 3%. Usually it's recommended to say about 2 to 5% biochar blend. This one was 3% into the concrete aggregate, and then just built and run as standard concrete. Now, for both cement slash concrete and bitumen, the primary benefits we're seeing, so we're taking away the carbon benefits here, but the primary industry benefits we're seeing are that, okay, so if someone's been in a hot climate and probably rainy weather, you've seen cracked roads and potholes and things like that. The reason these happen is because of the hot weather, or the issues increase because of hot weather and rain. Now, the tar inside bitumen traditionally is made from coal tar pitch, and so it's these kind of substances in the high temperature and the waters, they begin to crack and they begin to lose their strength. Now, biochar, I know it's very hard to see here, but maybe we'll put a picture up on screen, is actually very porous in nature, meaning it's quite springy, as opposed to traditional coal, which has been pressed effectively for thousands of years underground. Biochar is a bit more porous, is really the best word. So because of that, when it's used in these heavy agricultural settings, like a road that's taking constant load, constant heat and constant weather, it allows a bit of natural springiness. So it allows itself to bounce back. Now, we've got a road up in Darwin that has been laid about 3 years ago, and about 3 metres away from it, there's another road that was laid with biochar. Now, and if anyone's in Darwin, please reach out. We'd love to connect and show you this. But as we all know, Darwin, Australia, very hot, very wet. The standard road has already begun to crack and has potholes, whereas the biochar road, in the exact same scenario, the exact same weather, the exact same climate, has not begun to crack yet. So there's a lot of great work going on in the asphalt and also concrete. Now, one thing that's probably important to keep in mind is often these roads are laid for 20 years, concrete is put down for 20 plus years. So we are still at the early stages of seeing these trials, which have been done in the last few years, but a lot of them haven't reached the commercial life yet. Now, that's probably the biggest reservation in the industry right now. There's still a large adoption, but there is a very, it's a very conservative industry. So I think that's worth noting as well. Okay, so we won't go too much into energy or thermal, even though, our background was actually very heavily in metallurgical, so we do not know a lot about it. But at the moment, we focus on the net negative aspects. Now, the reason why we are focusing primarily on these two is really because, as we talked about, this carbon is sequestered underground. So we'll just give you that quick high-level overview of what we touched on earlier. Tree grows, tree falls down. That CO2, in the life of that tree, it sucks in CO2. As it falls down and dies and starts to decompose, that CO2 is released to the atmosphere. So we're stopping this happening. We're running it through our carbon negative power plant. And we are producing biochar, which is this solid locked in carbon. As we use it in these processes, that carbon will go underground, taking it out of the atmosphere. And again, the reason why we're focusing on these two industries is because there's quite a large amount of interest mostly from the voluntary market and mostly from private corporate buyers to offset their large carbon emissions, and whether that is from a data center or it's from oil and gas mining directly, and their shareholders want them to reduce their emissions. So they are purchasing the credits associated with this biochar. And biochar, out of most credits, are the highest trading. Let me correct that. They're not the highest dollar trading, but they're the most total value trading because they're a very, very valuable source of carbon credits. We'll do a whole nother video on carbon credits, explain in more detail. But I hope that gives you a better understanding of not just exactly what biochar is, and there's a lot of other videos that explain the chemical composition of biochar, we can go into that, but how it's used, and why it's valuable and why it's becoming very valuable. Okay, thank you very much. Looking forward to speaking to you on the next video.